Hey guys, we are going to continue today with 8.5, which is property of logarithms. And we looked over these rules in class. I wrote them here for you to be able to look at them and remember them. We have the product rule. If we have a logarithm at a certain base of two terms being timed, you can expand that by going log base b of the first term plus log base b on the second term. If we have, this is not right, x over y. If we have a division, we can also expand that by writing the two logarithms as a difference. And then if we have a logarithm of a number that is raised to a power, we said that power will come into the front and it just becomes that exponent log b of whatever number we have. And it will make a lot more sense once we work them out together. I wrote your example 1 on the table. They give us two values for log base 5 of 3, which is 0.68, log base 5 of 7, 1.209. And they say, go ahead and estimate log 5 of 3 over 7. Well, this is a division. We can go over here and go, I can write this as log base 5 of 3 minus log base 5 of 7. And now I have the values. It's 0.689 minus 1.209. 3, sorry, this is not a 9. And all I have to do is put it in the calculator, and it's about negative 0.526. Because they give us the value. So all I have to do is replace each one of them. But really the key was to expand from a fraction to actually the difference where I know both of the numbers and I can get a number out. Log base 5 of 21. They don't give me 21, but look at this. Log base 5 of 3 times 7, because 3 times 7 is 21. I can take these two numbers and do this. This is an addition. Log 5(3) plus log 5(7), which is really adding those things up, and that ends up with 1.892. We have a value for this, which is this, so all I have to do is add them up and get that value out. Log base 5 of 49. Can I write 49 as something with 3 or something with 7? We said in class, this is log 5(7) times 7, which becomes log 5(7) plus log 5(7). And now I have values. It's 1.209 times itself or plus itself. This becomes as 2.418. And we're done. This is how we go from a condensed version to an expand version. Now, as we move on to example 2, we learn how to expand when we don't have values, which means it's great. We don't have to actually do the actual math. We just have to expand. We have log base 2 of 7x to the second over y, if I'm not crazy. And then we have to expand it. Well, first of all, we're going to start with the beginning. This is a fraction. So this becomes log 2 7x to the second minus log 2 of y. We said this is done. There's nothing else that I can expand here. So this is just going to follow through. This is a product. 7x squared is 7 times x squared. So this becomes log 2 7 plus log 2x squared minus log 2y. That just follows through because nothing else I can do. This is done. This is just a 7. 7 is 1 times 7. It doesn't matter. But we have an exponent, which means we can now apply this rule, and these two can come into the front. This becomes log 2 7 plus 2 log 2x minus log 2y. And we're done, because this cannot be expanded anymore, this cannot be expanded anymore, and this cannot be expanded anymore. This is how it's spent. How we do expansions. Now, what if we get it expanded and we want to condense it? Like log 6 expand from a given stuff. Like if we have to, not expand by condense. If we have log of 6 plus 2 log 2 minus log 3. We talked in class, we first go by the order of operations. The first thing is going to be the exponential. I have a 2 in the front, which means it's going to become an exponent. It goes to the top here, becomes log 6 plus log 2 to the second minus log 3. And now we only have addition and subtraction. We're going left to right. This becomes log of 6 times, it's an addition, we're going backwards. 2 to the second is 4 minus log 3. And now all I have to do is that subtraction, which becomes log 6 times 4 divided by 3. And we're going to finish this math, right? Log of 24 divided by 3, which is log of 8. Look where we started. Look where we ended. So we went from here and we condensed it into a shorter form. You just go rules of operations and go one by one. So we're going to do first exponent, and then we're going to go addition and subtraction left to right as they come up. Okay? Now, we have learned the same thing about changing bases, and we really don't need to change bases because I already taught you how to do this on your calculator, but we're going to talk about this. It says, evaluate the expression log 3 of 7 using the common and natural logarithms. Well, here's the trouble with this. If I would have you to calculate this in your calculator, we already talked last week, you can't do it. But you can do it by doing log 7 over log 3. You would put this in your calculator. They're wanting us to use the values of example 1. We're not going to do that. And we get about 1.771. This is where we are. So we already learned about changing bases because we had to use the calculator. Anytime you need to change a base or to work a logarithm in your calculator, you can't put the base in, which means you're just going to take that log base 5 of, I don't know, 82 and change base. It's just going to become your log on the calculator, base 10 of 82, divided by the log of the subscript 5. And then the calculator will do the work for you. But that's how you kind of change base. Should you want to do it using a natural logarithm, it works the exact same way. If you go ln 3 of 7, again, you can't do it. You don't have that in the calculator. But you can do ln of 7 over ln of 3. You put that in your calculator, and it comes 1.771. What a surprise. It's the same thing you get. Okay? Example 5 talks about how we figure out intensity of noises, and I had you read the problem in the class, so if you need to take a minute and read it now too. But it really talks about this wonderful formula about loudness, and it's given by 10 log of the intensity of your sound divided by I0, which is defined as 10 to the negative 12. And the problem talks about two roommates that are playing their stereos. They want to know how much louder is when you play two stereos than when we just play one stereo. So let's go ahead and we named L1 one stereo, L2 two stereos, and they tell us that they're playing their stereos at an intensity of 10 to the negative 5. Let's go ahead and put this in the formula. We get 10 log 2 times 10 to the negative 5, and the reason is we have two stereos going, so I need to times the intensity by 2, all over 10 to the negative 12, minus just 10 log 10 to the negative 5 over 10 to the negative 12. And the first thing we're going to notice is that I have a 10 in common, both of them, so I can factor that out. I'm going to get a 10 out, and this becomes log of 2 times 10 to the negative 5 over 10 to the negative 12 minus log of 10 to the negative 5 over 10 to the negative 12. And if you want to do this in one move, you can. I'm just going to go step by step. I need to bring the 10 to the top to get rid of that negative exponent. This becomes 10 log 2 times 10 to the 7th. This becomes positive, negative 5 plus 12, 7, minus log 10 to the 7th. I can now go ahead and use this, the product rule, and separate that. This becomes 10 log 2 plus log 10 to the 7th minus log 10 to the 7th. Oh, look at this. They cancel each other out completely. So I'm left with 10 times log 3, like log 2, I'm sorry. When you plug that into your calculator, you get about 3. That is how much the sound is about 3 decimals louder if you are playing two stereos and one stereo. Part B just says to generalize. You don't have that in your homework, so we're not going to cover that part at all. We didn't cover it in class. But this is how you do it. Also, if you're brave enough and you use enough parentheses to plug just all of this in your calculator, you will get about the same answer. I already tried it. But if not, you can go step by step and separate them. If you're just brave enough to put this in your calculator once you separate it, you're going to get the same answer. Or you can just work it step by step if you need to. That's about in 8.5. Happy homework.